Hello all and welcome back for another video. Today I want to cover array lists. We're just finishing the array unit, so we're going to start off the second semester with array list, which I know you guys have seen before. Hopefully we'll cover it in a lot of depth and learn something new. So array lists serve much the same purpose as arrays. They allow us to store, access, and manipulate several similar objects, variables of some sort, using a single data structure. This is a very consistently useful thing to do in programming, and array lists provide another way in addition to arrays and then stacks, queues, linked list, set, map, etc. to accomplish this. There are some important differences between array lists and arrays. The first small difference being that you must import ArrayList whenever you use it. It's not built directly into Java. It's part of the Java standard libraries. And so whenever you need to use an ArrayList, you have to have import java.util.ArrayList at the top of your code. Note that this is not important to know for the AP exam. Everywhere on the AP exam that you'd want to use ArrayList or anything similar, it'll already be imported for you, so you never have to worry about this on the test. The second more important difference is that unlike arrays, array lists are mutable. When I use mutable in computer science, I mostly mean that it can be changed. So we know that for arrays, the size of an array when you make an array is constant. You can't add elements in between other elements. The only thing you can do is change elements at specific spots. Array lists are much more flexible with what you can do with them. The size of array list can be changed, elements can be deleted or inserted anywhere in the array list. And you can navigate them and modify them in just about any way imaginable. This makes ArrayList really convenient for a large number of tasks that would be quite tricky with arrays. And in general, I think the major benefit of ArrayList over array is that it's extremely easy to use. It just lets you do what you want. Underneath, ArrayLists really are just arrays. If you go take a look at the code for ArrayList, ArrayList is implemented using array, and then all that happens is that the array is resized whenever you have too many elements and the array gets full. And then anytime you add something in the middle of the array list, it has to move every element of the array over individually, and the same for deleting. So ultimately, array lists just are arrays. And so, of course, you can do anything with arrays that you could with array lists, but array lists are quite convenient, easy to use, easy to understand, and so beneficial for a large number of tasks. When we declare and construct array lists, we need to use proper syntax, and it does look a little bit different from the syntax for arrays, so we're going to go over it here. The first most important thing is that, like arrays, when we're declaring array lists, we almost always declare the type of thing that will be held in the array list. So for instance, I have a line here, array list string names. This means that I have an array list called names that will hold string objects, and the only thing that it can hold is strings. This would be the same thing as if I wrote string array names. Similarly, I've made an array list of integer here called ages. Note here that I picked integer with a capital I, the wrapper class for int, instead of int like I would have for an array. Array lists can only hold objects, so primitives are not a choice. You cannot make an array list of int, double with a lowercase d, boolean, char, etc. None of those things can go inside of array lists. So whenever you do want an array list of integers, which comes up quite often, you have to use the capital I integer. Luckily for us, Java does a really smooth job of boxing and unboxing, of converting back and forth between int and integer and double. And so in general, we don't have to worry about it very much when we're actually using the array list, but we do need to know when we're declaring our array list and constructing our array list, it has to be capital I integer. And then if I wrote something like this, it would not compile. In addition to array lists with types like string and integer, we do have the option in Java of creating an array list without a type declared, with nothing here after the array list. I've called this things, but I think I meant things. When we make an array list of this type, by default, Java will make it an array list of what's called objects. Objects is a superclass that contains every other class in Java, and so anything can be stored in this. And we'll get more into the object superclass later, but the key takeaway now is that you can put anything in this type of array list. This sounds very convenient and quick, but it comes with a lot of potential downsides that mean it's almost never the correct decision to use it. The first reason is that it's difficult to read your code. It's much more clear to users of your code, including yourself in the future, when you declare what kind of thing is being held in your array list, so you understand what the purpose of it is, how it's used. Another reason, and maybe a bigger reason, is that time I remove something from an array list with this type, the type object, the compiler, the runner of your code will not know what type that thing you removed is. So if you try to call a method on it, for instance, if I think that I've removed a thing from strings, and I want to call the substring method on it, this will not work. The reason this won't work is because when I remove a string object from my array list, there's no guarantee that this is a string to our compiler, and so it doesn't know for sure if I can call a substring on this method. To fix this, I would have to first cast this string that I've removed to a string and then call substring on it. In general, this is an inconvenient thing to do every time you remove something from an array list, and it's much preferable to create this as a string array in the first place, or string array list in the first place. It saves us a lot of effort in the long run, and it makes your code more readable, and also importantly, it lets the compiler catch errors that otherwise wouldn't be caught until you run your program. So I would say that in general, even though that this is an option and it might be a tempting option to use, I think there will likely be never a time in this class where it's appropriate to create an array list that doesn't have a type declared. And in general, in your programming career, future, etc., you'll be unlikely to use this syntax. Now, one thing worth noting about all the declaration statements we've made so far is that we have not yet created an array list. These are just declarations of the array list variable. So as usual, all we've done is create a name or spot for one. We haven't made an array list. So if we tried to use our array list by, for instance, doing names.size or ages.add 20, both of these will throw a null pointer exception. We cannot yet use them until we've constructed the array list. So how do we construct an array list? Well, there's a bunch of ways, but the main way, in fact the only way that you need to know for the APN that we'll see in this class, is to construct an empty array list. Here I've written a statement that both declares and constructs an empty array list called example. Array list example equals new array list with parentheses right after the type. This constructs an array list of the specified type that's empty. You'll note here that I put an E. E is a common letter used in Java, and particularly in the context of array lists, and it's called a generic or a wildcard for the type. Basically, this is saying E can be any type and replace E with whatever type that you want. So E could be string or double or integer, etc. So if I wanted to make an array list of doubles, I would say array list double scores equals new array list double. And I've replaced both instances of E with double. So whenever you see E, particularly in Java documentation or on the Java quick reference that's available to you on all your exams, know that E is just standing in for any type that you want it to be. All right, next thing I want to cover, and last thing I want to cover, this will be a short video I think, is all of the standard array list methods that we need to be able to know and be able to use for our test. So I've used these standard methods in a specific way, or I've shown them in a specific way that's like the way that they're shown on the documentation, the API for ArrayList, and also in your Java quick reference. So when we write method headers, what we typically write is the return type of the method, the name of the method, and then in parentheses any parameters that the method requires. This is called the method signature, and this is how methods will be represented for us. So below here I have the 6 methods that you need to know, and up here I declared a array list, num list of integers holding 17, 10, -3, and 41 that we're going to use to show some examples of all these methods. So the first method to cover is int size. This is a method that returns the size of an array list, much like .length is for an array. And so if I want to call this, I would do numList.size, and this would return to us 4. Note here that unlike dot length, we have parentheses at the end. This is because this is a method and not a constant. Array lengths can't change, size can, so this might not always be the same thing. The next method we have is Boolean add on E object. So remember that this E just means whatever type your array list is. So in the case of our array list up here, numList, E object would be some sort of integer, either capital I or a lowercase I int, because it would convert it to an integer for us. Boolean add adds an element to the end of a list. So there's no similar thing for arrays, because arrays cannot add things to the end. You can add something as the last thing, but not past everything else that's currently in the array, because the size of an array can't change. And I would call this by saying something like num.add10, and after this, if I did num.add10, our array list numList would look like this. We've added 10 to the end. Note also that the size has changed of array. We now have 5 elements instead of 4, but nothing else has changed. Another thing to note that I've skipped is this Boolean. I don't know why Java has decided to make it work this way, but this method always returns true if you've successfully added something to the list. I can't think of a time when that would be useful for you, but it's worth knowing that this method returns true on a successful add. On an unsuccessful add, it just throws an error. And so this method can't return false, which makes it weird that it returns a Boolean at all. But I don't know. Ask the creators of Java. Our next method is another add method. For ArrayList, add is overloaded. There are multiple add methods that are differentiated by the types of parameters you send in. So your compiler will know to run this add method if you give it an int and an object, and will know to run this one if you give it only an object. This add method adds at the spot index in your list. So if I, for instance, called numList.add3, and then I wanted to add the number -100, well, I would count to spot 3, 0, 1, 2, 3, and then in that spot, I would add the number that it's been specified to add, and everything else gets pushed to the right. So 41 and 10 got moved up an index, the size of my array list increased, and -1 got inserted inside them in the middle. Note that this method, for some reason, is void, does not return true if you successfully added anything. Again, don't ask me why, that's just how it is. All right, 3 methods left. We have a get method. So get is starting to be more similar to our array methods. This is the same as saying array index. This will just return the value of in our array list at the specified spot. And note that its return type is E. That's because it returns whatever type of object is held inside of your array list. So if I call numList.get and spot 4, this will get the integer at spot 4, 0, 1, 2, 3, 4. So this will return 41, which is of type integer, which is being represented by this E. So this returns an integer, specifically 41. Now we have ESET. ESET is similar to how we have set things in arrays. This is similar to saying array index equals obj. It will change the element at the index to whatever object is. So if I say numList.set 1 to 0, it's going to find the element at spot 1, which is 0, 1, 10, and that will change this to a 0. This method also has the return type E. It also returns something in my list, and specifically, it will return the thing that was in the list before you changed it. So we changed the 10 to a 0, so this method is going to return the 10, what we replaced with our new element. And then our last method here, remove, at index, remove something and moves everything. It doesn't change it to something, it just smushes everything together to fill the gap. So if I call numList.remove 2, it will find the element at spot 2, 0, 1, 2. It's negative 3. It's going to delete this element negative 3. The size of my array list decreased by 1. There are now 5 elements. Everything to the right of the negative 3 got shifted 1 spot to the left, so all the indexes of these elements are different. And as set does, this returns the element that was there before we removed it. So returns negative 3. Now, one last thing to note before I end the video is that a couple of these methods we've just talked about change the size of my list. Remove and then both add methods will change the size of my list and sort of modify the list in place. This is something to really watch out for because it changes the behavior of array lists compared to arrays. Specifically, when we are iterating through a list, when we're going through each element one at a time, if we're changing the list while we're doing it, it makes the for loop not always behave as intended unless we pay special attention to it. So we always have to be really careful about using remove or either of the two add methods because they're going to affect our code in ways we might not predict. That's it for today's video. In the next video, I'm going to cover iterating through array list and also common array list algorithms, and then we'll have a quick video at the end of the week on searching and sorting to conclude our array list unit. Can't wait to see you guys in class and hope your night goes well. Thanks.